So this one says, find the measure of the central angle of a regular polygon who has 24 sides. How do we just find the central angle? Good. 360 divided by 24, which is 15 degrees. Okay, that's all we had to do for that one. The second one says, find the area of the regular polygon. So first of all, we need the same information every time for area, right? If it doesn't already ask for perimeter, then we can use 1/2 A and S. If it had already asked for perimeter, then we could have done 1/2 A times P, where the little a is the apothem, right? The n is the number of sides, and the s is the length of each side. So if you look at this object that's there, how many sides are there? 5, so n is 5. Do I have the length of each side? Yep, it's 8. And then the apothem, 5.5. So area is 1/2 A, which is 5.5, N, which is 5, S, which is 8. Yeah, you can cancel the half into the 8 if you want to. 5 times 5.5 times 5 times 8. So I could have done it that way. Probably if without my calculator, I certainly would have tried to make it as easy as possible on myself. And that would have been 5.5 times 20, right? And you should get 110. Good. And this time it's centimeters, so we say centimeters squared. Questions on that one? Yep. Yeah. You want to keep practicing the units. So everything that has area is whatever the unit is squared, right? And if you're talking about perimeter, it would have just been centimeters. Okay, number 3, find the area of the regular polygon. Again, same formula. So A equals 1/2 A NS. On this shape that I've got here, what's the number of sides? 6. That's a hexagon, right? The length of each side is unknown so far. But I do know apothem is 6√3. So here comes the work of the special right triangles, right? So I have to take my 360, divide it by 6 to get the central angle. That's 60. That would be the big angle here, right? That's 60. I'm going to cut that in half. 30 at the top, 60 on the bottom. And I can do either triangle because those are two congruent triangles. So in my relationship of the side lengths in my 30, 60, 90, what goes opposite the 30? A. Opposite the 60? A√3. And opposite the 90? 2A. So you actually have two side lengths here, right? You've got the 2A equals 12, and you've got the A√3 equals 6√3. Pick whichever one you want to solve for. Either way, good. Either way, A equals 6. So if I did the 2A, which probably you guys, I would assume, would pick that to avoid the root. A is 6. That means this segment here is 6. And then to get the whole side length, I have to do what to that? Double it. It's 12. And a 60-60 triangle, which would have been the big one, the radius is going to be the same as that side length, right? Should make sense. That's equilateral. So now I've got my side length is 12. And then I just plug it in. 1/2, the apothem, which is 6√3, the number of sides, which was 6, and the length of each side, which is 12. And then you can do 1/2 of 12, 1/2 of 6, or 1/2 of the other 6. It doesn't matter. And I get 6 times 6 times 6, which is 216, and there's still the √3, and it's centimeters squared. Questions? So again, hexagon's the one that you can do a 30 at the top, right? Because it'd be 60 cut in half. We're good on hexagons? Yes? Yeah? Questions? Okay, then comes 4, which we'll get back to tomorrow, because that's when you need a calculator. All right, so this was 28 from the homework. It said find the area of the shaded region. So the outside shape is what? A circle, and then the inside is the triangle, right? So I have to take the area of the circle and then subtract from it the area of the triangle. How do I find the area of the circle? Pi r squared. Michaela, this is the one you asked for, right? So 8 is my radius. This would be pi times 8 squared, or 64 pi. That's the circle. And then I've got my equilateral triangle on the inside. So I know the radius. I don't know the apothem. And I don't know the 1/2 the side. Let's just call it x, because then we'll double it to get the other side. So in an equilateral triangle, 360 divided by 2 would give me 120 all the way at the top, the central angle. Cut that in half and I get 60 degrees. Yep. Opposite this 30 would be A. Opposite the 90 would be, or the opposite the 60, sorry. A root 3. Opposite the 90, which is that 8, is 2A. Good. A is 4. This one is 4. This one is 4 root 3, which makes the whole side twice that. 8 root 3. Now I've got area of the triangle, 1/2 A, n is 3, length of each side is 8 root 3. 1/2 of 4 is 2, 2 times 3 is 6, 6 times 8 is 48 root 3. And I would subtract that. Why what?
Because we did it differently, but we got the same answer.
Okay.
Well, we did it differently, and I forgot why we did something. So I'm just like,
Okay.
But your 8 is the radius for the circle too, right?
Yes. Yeah. Okay, then we asked for, wait, 23 and 24, right?
For 28, you wouldn't you would.
So 23 gave you the radius. So this, let me do this one the way that we didn't do the warm-up, which is that this diagonal would now be 28. And then this is a 45, 45, 90 triangle where A, and A root 2. So if 28 equals A root 2, I would divide by both sides by root 2. A would equal 28 over root 2. Rationalize it. And simplify it. So those are your side lengths. And then a square, I can just do side squared. So 14 root 2 squared would be 14 squared. That's 196, right?
Yes.
Thank you. 196 times 2. 392. Unit squared. Oh, yeah. And then I needed to do 24, right? Who asked? Somebody asked for 24. Yes? Yeah. Okay. 24 gives you the radius. This is a hexagon, so 360 divided by 6 is 60. Divide that by 2, it's 30. So at the top, I've got 30. This would be my A root 3, and 10 would be my 2A. So A is 5. Half the side length is 5, making the whole side length 10, and the apothem would be 5 root 3. So then it's 1/2 apothem 5 root 3, number of sides 6, length of each side 10. I can do half of 6 is 3, 3 times 10 is 30, 30 times 5 is 150 root 3. Again, didn't give you a unit, so unit squared. Everybody good? Yeah? Okay, so we're going to go one more section after today, which is geometric probability, which is like kind of like, actually not one more section in the book. We're also going to review some areas that you should already know, rhombuses, parallelograms, trapezoids, all that stuff. That's tomorrow. Monday will be the geometric probability, which is kind of like applying those shapes inside other shapes. And then we'll review Tuesday, Wednesday, test on Thursday. So test a week from today. Yes. Okay. So yesterday we talked about the parts of the polygon, all that vocab. We talked about finding the central angle. we talked about the formulas for the areas, which you're going to use again today. 1/2 AP or 1/2 ANX. And then we skipped, right? We stopped at example 3, which 3A, which is a pentagon. So when the object is not an equilateral triangle or a hexagon or a square, and it doesn't give you S and A, then we have to use SOHCAHTOA. So that's why our calculators come back into play, okay? So A says find the area of a regular pentagon inscribed in a circle of radius 8. So you can draw out a pentagon. Mine won't be good, but it would have 8 sides, right? So 1, 2, 3, oops.
5.
A pentagon. Thank you. I was just making sure you're paying attention. 1, 2, 3, 4, 5 sides. So I already know that. That's the one thing I know from its name, okay? I still need the apothem, and I still need the length of each side. The only other piece of information I have is my radius, right? So the radius goes from center to vertex. That's going to be 8. I don't have the side length or the apothem. But what I do know is if I take 360 and I divide it by 5, I get 72. That would be this whole big angle. And then I need to make a right triangle. So I add the apothem in there, which is dividing that by 2. And now I have 2 triangles that are congruent, because I would still have hypotenuse leg. And the angle at the top is 36. You with me so far? Yeah. So I'm going to actually drag out just one of these triangles so that we can look at it a little bit better. The radius, which is 8. This is 36. Now I need this side and this side because the x is half the side length and the y is the apothem. How could I find that? Let's say I want to solve for x first. Where's the x in respect to the 36? It's opposite. Where's the 8 that I'm given? The 8 hypotenuse. So what trig function is opposite hypotenuse? Sine. So I'm going to say the sine of 36 equals x over 8. Do you remember this? Yes. So then what happens when the number's in the bottom? I multiply. And I would do 8 times the sine of 36. And I'm going to round it to the nearest tenth. That's 4.7. So this segment, half of my side is 4.7. You with me so far? So I have to double it to get the S. 9.4 is my S. Now the other thing I have to find is my apothem, which we just labeled Y. So I'm going to go to cosine. I could actually use tangent at this point, but what's the benefit to using cosine over using tangent? Good. It doesn't have a decimal. We didn't round it. And sometimes smart people make mistakes. Yes. Where we could get the x wrong and then we get the y wrong too. So I'm going to stick to the information that I had in the beginning, which is the 36 and the 8, which means y is adjacent and 8 is hypotenuse, and that would be cosine of 36 equals y over 8. Again, it's in the bottom, so I multiply. Good. Y equals, whoa, explain everything may have been overloaded. You don't miss it, you said? It's so fun, Miss Ferrier. 6.5 is my apothem. Everybody good so far? Yeah? Okay, now I got all the information I need. I got to do 1/2 A N S. Best part is you still have your calculator, right? So I'm going to enter 1/2 as 0.5 times 6.5 times 5 times 9.4. And I get 152.75. If it asks me to round to nearest tenth, that would be 152.8. Didn't give me a unit, so it's units squared. Questions? Find the area of a regular octagon with side lengths 10. See, I was like getting prepared for the octagon. Octagon has how many sides?
8.
8. Side length is actually given to us this time. It's S. What I don't know is my apothem. So I could, again, go through and draw out an octagon, but really all I need is that central angle in it. So you could just draw yourself your little central angle. I know the degree at the top here would be 360 divided by 8.
That's
45. And then the apothem cuts it in half. 22.5. And this whole side is 10. So how did I just do to that 10? Good, I split it in half, so this is now 5. All I need this time is the apothem. Have to use tangent. Good. So the tangent of 22.5 equals 5 over A. And now the numbers in the top, with these I do? Divide. Take that and divide it by that. So 5 divided by tangent 22.5. 12.07. I'm going to round it to 1. Nearest 10. So then area, 1/2, 12.1, 8, 10. $484 units squared. Because this is opposite and this is adjacent, so opposite goes in the top, adjacent goes in the bottom. When the number's in the top, right? Normally I would multiply by A on both sides and then divide by 5. So now I could just do the reverse. I mean, not divide by 5, divide by tangent 22.5. Now I could just do the reverse.
So now in the homework we do the ones that we crossed.
Correct. So the ones that you either crossed out or didn't highlight yesterday, those are the ones that you're gonna do. I'll just duplicate your assignment for tomorrow, and you'll just submit just those. So it's not a lot, but you'll do just those. So if you don't have questions on the homework, you can start it, like from last night. Okay, you can start tonight. If you have those questions, I'm gonna go back to them now. Everybody good? Yes? Okay.